Hi chaps, so yes, the job today is to watch a video and take some notes on speed and velocity and what the difference is between them. So let me just get it so my pen works by hitting that button there, and it should be working. Yes, wonderful. Okay, so let's get cracking. What is speed, what is velocity? So the first thing we're going to talk about is velocity, and this is like the first building block of all the kinematics. What is velocity? Well, first of all, velocity has the symbol lowercase v. I don't know why I did that quite so fancy. Let me do that again. V, and it is a vector. It has that little vector arrow on it. Now, velocity is defined as the rate of change in an object's position. Okay, so the change in an object's position is displacement, right? Displacement, delta x, which is also a vector, is equal to the change in an object's position, so it's the final position minus the initial position. So velocity is the rate of change of that. So what that means is velocity is the displacement over time. Whenever anything is the rate of change, that means it's that thing divided by time. So the equation I want you to write down is this one. V with a little vector arrow is equal to delta x with a vector arrow that I forgot to include over t. Displacement over time. Now, a couple of other things. We need to know that it has a unit, and bearing in mind that in physics we are always going to be measuring distance and displacement in meters, and we are always going to be measuring time in seconds, then I can tell you that the SI unit we're always going to use is meters per second, because again, delta x is meters, time is second. And the other thing is velocity is a vector. Again, because displacement is a vector, this forces velocity to be a vector. If an object displaces negative, then the velocity is negative because it's going backwards. And yes, so velocity can either be positive or negative depending on if the object is moving in a positive direction, so the x numbers are getting bigger, or a negative direction where the numbers are getting smaller. So that is velocity. Feel free to pause it here if you need to write that down, because I'm going to move on and talk about speed. So what is speed? We don't really talk about it too much in AP Physics. The speed is just the rate at which an object travels over a distance. Speed is distance divided by time. Velocity was displacement divided by time, but speed is just distance divided by time. Or speed is equal to d over t. Really, we don't use it too much, but I just want to make sure we understand the difference between the two. Distance and displacement are different, as I believe we have talked about. It's still going to be in meters per second speed, because it's still the distance. We're still going to measure the distance in meters and the time in seconds. So it's still meters per second, but it is a scalar because there's no little arrow here. And again, distance is a scalar. It doesn't happen in any direction. It's just how far an object has traveled. And there's a beautiful piece of alliteration, because velocity is a vector and speed is a scalar. Isn't that lovely? It's almost as if they planned it. So speed is a scalar, velocity is a vector, and what this means is speed cannot be negative. It's always positive, right? It's always a positive value. Any scalar is always a positive value. Alright, so where's my little thing? I told you that the unit is meters per second. I was not lying, but just so you know, it can in theory be any unit of length over any unit of time. So miles per hour, right? Miles is a unit of length. Hour is a unit of time. Kilometers per minute is the same. Kilometers is a unit of length. Minute is a unit of time. Inches per month, like hair grows at like half an inch per month, right? So inches is a distance, is a length. Month is time. But in physics, we always boil it down to meters per second. Even if this is like a crazy high number, like the speed of light is 300 million meters per second. It's pretty much the fastest thing anything can go. We still always put it in meters per second. Alright, so let's make sure we know what we're doing here, and let's just do a quick concept check. Where I have a car travels 60 meters down the road in 12 seconds. Calculate the car's velocity. I was going to do speed as well, but it's going to be the same. So car travels 60 meters down the road in 12 seconds. Calculate the car's velocity. All right, here is what I am thinking. I am thinking of writing down all the information I know. 60 meters. That is the displacement, right? Because what we're doing is we're assuming it starts at, the reference frame starts at 0.0, right? At time equals 0. And then 12 seconds later, so time equals 12 seconds, it's 60 meters away. So delta x is equal to 60 meters. Time is equal to 12 seconds. And I want to find the velocity is equal to a big fat question mark. So all I'm going to do is write down the equation. Velocity is equal to delta x divided by t, and all I have to do is plug it in. It is this simple. Look at that. 60 meters divided by 12 seconds. 60 divided by 12 is 5, and it basically gives us a unit, which is meters per second. How about that? That was a piece of cake. Alright, that last question was remarkably simple because it was what we call a plug and chug problem. You just got the equation, you have the numbers, you just plug in the numbers, you're done. This question is a little bit trickier. A car has a velocity of 5 meters a second. How far will it go to? Will it travel in 8 seconds? Okay, this is a little bit trickier, but it's not impossible. All I'm going to do is write down the things that I know. So I know that the velocity is, oh, my pen's not working. Wait, work pen. Oh, no, it went, where you going? Go back. Okay, the velocity is 5 meters a second, alright? So let's write down the stuff I know. Velocity is equal to 5.0 meters per second. It travels for 8 seconds, so this is my time. My time is equal to 8.0 seconds. And I'm trying to find how far. This is delta x, right? So delta x is equal to a big fat question mark. Okay, so what am I going to do? I've written down everything I know. I'm going to go back to the equation, which is velocity is equal to delta x over t. The only thing is, right now, I want to solve it for delta x. This is delta x here. So how am I going to do this? There's 2 ways you can do it. Number one is you can plug in the numbers. I don't want to do it that way because we're smarter than that. And I really want to get us used to, straight off the bat, kind of thinking and rearranging algebraically. So what I am thinking is I want to get delta x all by itself. I want to solve this equation for this. And right now what I have is I have delta x divided by t. So if I want to get delta x by itself, all I got to do is I got delta x divided by t. If I multiply it by t, oops, I don't know why that happened. Let me do that again. If I multiply it by t on this side, then the 2 t's are going to cancel out. But whatever I do on this side, I have to do it on this side. So I have to multiply it by t here. So what this does is it gives me a new equation, which is t multiplied by the velocity, or time multiplied by the velocity is delta x. Or let's just rearrange it. Delta x is equal to the velocity multiplied by time. Time multiplied by velocity is all the same thing. And let's plug it in. Delta x is equal to the velocity, which is 5.0 meters per second multiplied by 8.0 seconds. And I got 5 times 8 is 40. And here's the beautiful thing. Look at this. I got meters per second multiplied by second. This second cancels out with that second, and it leaves me with the unit meters. This is wonderful news. We are tickety-boo done. Happy days, eh? Alright, so if you're happy with that, we're going to do the third iteration of that problem, which is a car has a constant velocity of 5 meters a second. How much time will it take to reach the traffic light 130 meters away if it maintains this velocity? So if it's traveling at a constant velocity, how much time is it going to take? Okay, so again, I'm going to do everything I did before. I'm going to write down what I know. Has a constant velocity. Oh, my pen's not working. Why's my pen not working? I don't know why it resets that every time. Has a constant velocity of 5 meters a second. All right, so my velocity is equal to 5 meters per second. How much time Alright, so that tells me that time is the big fat question mark. How much time will it take to reach the traffic light 130 meters away? Okay, again, assuming the kind of question starts at x equals 0, the traffic light is 130 meters away, so I need to travel a displacement of 130 meters. And I need to solve it for time. Alright, so what am I going to do? Easy enough. I'm just going to write down my equation. Velocity is equal to displacement over time. This is the same equation I started with each time. The only problem now is the thing I'm trying to solve for is the time. And this is a pain in the butt because it is on the bottom. And I can't do anything while it's on the bottom. So here's what I'm thinking. I'm thinking to myself, I need to get this time on the top of the equation before I can do anything. So let's do that. Right now I've got delta x divided by time. Let me go ahead and multiply it by time on this side. Let me go ahead and multiply it by time on this side. Now the time's going to cancel out here, and it leaves me with the equation just like I had before. Time is equal, time multiplied by velocity is equal to the displacement. But that's not what I want. I want to get time all by itself. So right now I have time multiplied by velocity, time multiplied by velocity, so let's divide it by velocity. That's doing the opposite thing, right? But whatever I do on this side, I've got to do on this side. These are going to cancel out. And so what that gives me is the equation time is equal to the displacement divided by the velocity. Okay, let's see if this works. So what I'm going to do now is I'm going to plug my numbers in. The displacement is 130 meters. The velocity is 5 meters per second. 130 divided by 5, 130 divided by 10 will be 13, so I guess it's 26. But what about the unit? Well, here's the funny thing. What I basically have, if I look at these units, I have meters divided by meters per second. Well, this is a complex fraction. I don't know what you remember about math. And don't worry too much about this, but just so I can kind of prove a point, I'm just tidying that. Oh god, that's even worse. If you have a complex fraction, the way you get rid of it is you take the fraction in the denominator and multiply the numerator and the denominator by the inverse of the denominator, right? So I got meters per second underneath. I'm going to multiply it by seconds per meters on the bottom. But if I do that on the denominator, I have to do the same on top, seconds per meters. Now, why am I doing this? Because everything cancels. Now look, meters cancels with meters, seconds cancels with seconds down here, and then I basically have meters multiplied by seconds over meters, so the meters cancels out, and it gives me the unit seconds. 26 seconds, is that the unit of time? It is. I got the right unit, so I have done it right. And this right there is my answer. So they are the 3 iterations of a real simple velocity question. Now we can do a bit more to that, but I think I'm going to call it for this video because I'm at 13.5 minutes, and I think that is enough. So I think I'm giving you more instructions on what to do today, but I'll leave it there, and yeah, I will be checking your notes in due course, but in the meantime, Wyatt out.